hope for lots of diversity, dignity, respect, and decency at all these meetings. Please don't engage in harassment. If you believe you've been harassed, notice that someone else is being harassed, or have any other concerns, you're encouraged to raise your concerns with the ombuds persons. I'm going to run through some of the logistics here and then introduce how we're going to run the session, the multiple sessions. If you're in the room, please use the QR code, sign in that way, because that helps us track folks from the registration and statistics perspective. If you'd like to join the mic queue, you'll need to use Meet Echo to do that. If you're on site, and that's us mostly, keep your audio and video off. That's also the participants. Make sure your audio and video are off for our remote participants until you're asked to present. Headsets are strongly recommended because the audio is a lot clearer. Although, Matt, we could hear you perfectly. Different resources are
Cool.
at these different links. We're going to start with two fabulous speakers that we have. The first person, and we'll give you a go in a second, Matt, as we get the slides up, is Matthew Rantanen. He's a director of technology for the Southern California Tribal Chairmen's Association, or the SCTCA, and director of the Tribal Digital Village TDV Network Initiative. Matt's a well-known person in connectivity alone, but also in tribal connectivity or indigenous connectivity. He's going to speak about the tribal broadband boot camps, which are a really great incarnation that started 3 or 4 years ago. But Matt will tell you about that. And our second speaker is Can the web benefit from CBOR? That's Martine Sophie Lenders, and she's here with us, PhD student and research assistant at Frey University. Frey, got it. Okay, we'll fix that. And then we have a Leo panel, and Curtis will moderate that. And you can see the list of great speakers: Dr. Joanna Kuliza, Dr. Bernard Gur, John Ping Pan, and Tony Lee. Without further ado, we're going to skip over to Matt.
And I'd like to just structurally, it's 20 minutes for Matt and then 10 minutes of questions. We really like questions. There's a lot of space for questions. So let it bubble up in your mind. You'll have a spot to talk when Matt's done.
And Matt, just let us know when to advance the slides, so we'll do that for you.
Sure, no problem. Thank you very much for inviting me. It's a pleasure to be here. I wish I could be there in person. There's entirely too much going on the calendar these days, and traveling seems to be hard to break the Zoom cycle. So I'm coming to you from Southern California, and I'm going to talk to you about the tribal broadband boot camps. So long story short, tribes have been trying to get communications on their reservations, since communications have been a thing. And the government relationship with the tribes is a trust relationship where the government is supposed to be able to supply resources to those reservation areas. And the federal government has intended to do that through incentive programs with existing telecom providers. And they have attempted to do that anywhere between 6 and 10 times over the last decades to be able to provide communication services to reservations. And the telecommunications companies have figured out how to take the money and avoid the opportunity to deliver services through loopholes in the program. Requirements of coverage areas only being 98.5%. Really easy to leave out indigenous populations when you can leave out 1.5% because the tribes are within that number. So, we're coming along trying to figure out how to build broadband. Several tribes, upwards of 30 networks, have been started prior to the end of 2019, early 2020. Obviously, world pandemic hits, creates a catalyst in every market for broadband because those that were disconnected were, left behind on education, job, just communications in general, resources. And so the tribes have been feeling that forever, but now the rest of the world was feeling it. So money started to be discussed. And for the first time in my career lifetime, which is now 23 years in this space, we see an actual meaningful amount of money flow to tribes. So they carve out $1 billion in the first effort, and they've announced an open window for application for that to build broadband in communities. It is mid-pandemic, and we are fighting to figure out how to keep our communities safe when we're also trying to figure out how to apply for this, $1 billion in funding throughout Indian countries. There's 574 federally recognized nations in the United States, and it is a competitive process, as $1 billion does not go that far when you divide it up by 574. So we had an outcry from reservations, from tribal leadership, from tribal broadband potential builders, from people that were actually building broadband, and those that wanted to manage their communications services and apply for these funds. There was an outcry for information, for support in how to structure applications. Those that were unaware of what is broadband, if you will, getting their head around the concept of managing their own communications efforts, and basically stepping into a new realm. So they manage a lot of times their own water systems. They manage sometimes their own electric grid, green energy grid, depending. They manage a lot of their utility resources and different things. But broadband is a new animal. So many tribes reached out to us, and we were very open to going to reservations and having sessions with tribes that needed support. But all of the reservations were closed due to restrictions for the pandemic, and they did not want any outsiders coming in to spread potential issues. So I have some acreage in Southern California, and we chose to support this by inviting people to my house in Southern California, and we created what we are now calling the Tribal Broadband Boot Camp. And it hosted 29 people from seven different tribes the first round. And we were very focused on wireless technology because they had just received, most of those tribes had just received their 2.5 gigahertz license from the FCC through a tribal priority window that was opened for them specifically. So they were interested in how to deploy their 2.5 gigahertz, and then how to maybe find funding, and then how to apply for the federal funding that was coming along. We had a 3-day event. It was miserably hot. It was 103 Fahrenheit for 3 days. And we hosted it in what I call my zombie bunker. It is a 3-story Connex container stack and in Southern California in the desert. So we had a very successful event. To our surprise, there were tears at the end of happiness, of people realizing that they weren't doing this alone. They had other tribes that they could rely upon, they could talk to and work with if they had questions, and that they weren't focusing on this massive problem for finding a solution on their own. So this is all in partnership with my friend Christopher Mitchell, who runs a program about municipal networks at Institute for Local Self-Reliance. And the first boot camp was funded by Internet Society, and we thought that this was an overwhelming success, but we were afraid that it wasn't true to keep going, whether or not it was going to be successful. So we actually decided to have a second one just to prove that it was, as good as we thought it was. So we had 45 people come from 13 tribes again, and this time we brought in fiber optics and wireless, and focused on, total network solutions, business models, the application, the funding cycle, and things like that. And we were able to make an even bigger impact, and it's measurable, just purely at the end of every event. We sit around in a circle and, who are you? Where'd you come from? And, what did you get out of the event? And just the testimonial from folks was enough. But what we did see evolve out of that was one of the tribes in Northern California had a wireless solution designed, and they were applying for the federal funding, the first $1 billion of federal funding. And they had come to this second boot camp. They had been to both boot camps. They came to the second boot camp and got access to a demonstration on splicing fiber and the management of fiber assets. And they actually got to get hands-on with fiber, with a fiber splicer, and splice their own fiber and learn how to do some of the parts of that. And it was very influential, as they thought fiber was a scary monster. And once they got their hands on it, they realized that it was not as complicated as they thought it was going to be. It actually presented some ease of use in comparison to wireless in some situations. And so they went home and they tweaked their application. They were awarded $65 million to build a fiber to the home network. They're very much the poster child of what is possible in Indian country when you take on your own communications responsibilities. And so they have a $65 million grant from NTIA, National Telecommunications Information Administration, and they are now a partner of the state of California in California's attempt to build roughly 8,000 to 10,000 miles of middle mile fiber that's missing in the infrastructure of California's networking. And they're partnering with the state of California and building I think it's a 23-mile section, obviously reducing their costs on building that for themselves, but then also operations and maintenance contracts, and actually being building a sustainable business out of this. So we're super excited. Go ahead and advance the slide, Jane. We are super excited to share that we've hit 72 tribes. This is not all their logos. I tried to grab them all, but 72 tribes have attended after 14 events, and we have over 400 people that have been in at the boot camps. So this is just a cross section of a bunch of them, but you can see, if you just pick one and look at it. I mean, Gila River Indian Community, one of the tribal telcos, the 11 tribal telcos. You have Mohawk Networks, which is a very established network in upstate New York. You have, Tohono O'odham, which is the Southern Arizona tribe, the fourth largest reservation in the United States, and very, very efficient utilities program developed there. There's a number of wonderful things, and you have the flag for the nation of Hawaii is at the top with the white, yellow, and black, and that's Pu'uono Waimanalo, where we were able to attend and help build a network there through the Indigenous Connectivity Summit. And then those members of Waimanalo were able to attend boot camps and become instructors in that process, on and off. We very much are interested in elevating those that are building and that are finding solutions and creating solutions for their own communities, to instructing others and sharing their experience with others as experts. So we draw from multiple people throughout these tribal nations to be able to engage with our next boot camps attendees. Go ahead and advance again. So this is just a picture cross section of some of the attendees. We very much enjoy being in the room together and finding solutions. The bottom picture with a cluster of people is with a landscape behind. That's the Hoopa Valley Reservation. That's the reservation I was talking about that was awarded $65 million. And you can see their community behind us, or behind us, the people there. They have to serve that entire valley, which, if you can imagine, just looking at the landscape, is cut off from the rest of the communications efforts of the world, because they're surrounded by mountains on all sides. And they have one valley that's long that drains out through the south, and they're building fiber up through that south to be able to support that community and then spread it around that reservation. Very excited to have had all the attendees that have participated in the program. It's a wonderful group of people. Go ahead and advance again. And so recently, about 5 events ago, Christopher Mitchell and myself and a handful of the instructors decided that the space at my house, I have 24 acres that's available for use around my house. And it made a lot of sense that when we were asking vendors for sample products so we could get hands-on with, you know, fiber strands and different things like that to share with people so that they were familiar with the products that are used to do this. In engaging some of these vendors, it was very apparent that we were able to get things donated, quite a bit of stuff donated for free, and we were looking at the amount of stuff that we were able to get to us, and we thought, why, we have this space, why don't we just create a network that people can actually function with and make a broadband playground? So at my house in Southern California, we have created this network. As you see on the left hand side of the slide there is a effectively a fiber ring, but looks like an upside down triangle a little bit. But between the two buildings at the bottom middle of the map, they're connected, and then the green line and the blue line go down to another building, and then they spur off to a tower. And so what we've created is 3 splice points, a tower for wireless demonstration, and an incoming, the yellow line is incoming from a service provider that provides internet to my household. And so we've created a live network that is supported by Calix and by Research and Education Network folks, Merit, and a handful of others, NSRC, which some of you may know. And so we have a really interesting demonstration that is in the ground and live, where there's about a quarter mile of fiber used in the situation, and there's you know, all of the things that you could think of to be able to play around and manage you know, fiber applications and wireless applications off of a fiber feed and managing a network. So when we host it in Southern California, we host a couple events a year there, and then we like to be out on reservation for the other events. But when we host in Southern California, we take it up a notch to that upper level, intermediate, and advanced, so that we can engage folks on the ground, in the dirt, messing around with fiber. We can actually cut the network, and we can repair the network. We can, you know, set up a wireless link and cause it to have failures and do troubleshooting and management. And people get to really see the scale of something rather than just doing it on a desktop in a room like you're sitting in today. So the tribal broadband boot camps have been a wonderful success. Our next one is in August at Lac View Desert up in Upper Peninsula, Michigan, with one of the tribes there. And we have a schedule that's being fleshed out for the end of the year and all of next year throughout the United States and down in Southern California. I'd say the biggest success of the tribal broadband boot camps is this byproduct of getting everybody together, and that is we have over 400 participants from 72 tribes that now work together in a network of people talking to each other, vetting vendors, vetting consultants, contractors, you know, sharing experiences, sharing resources. And I am no longer the bottleneck. I am no longer the point person for contact. All of these people now know each other intimately. They've broken bread together. We host this with very food centric. We have 3 meals a day provided. Nobody has to find food. It's very, you know, very much catered to a comfortable and sort of safe space for people to ask the simplest of questions to very advanced in the weeds, you know, high level description questions. And we're super excited that there's this network of people. They all communicate with each other on Discord after the fact. We have a multiple channel Discord that is constantly active. My phone is constantly buzzing with people engaging on Discord, which is wonderful because every one of those is something that might have been, hey, Matt, how do I get a hold of so-and-so? Or, hey, Matt, do you know where a vendor that will provide this? Or, hey, Matt, can you do this? And I, as one person, I can't be that conduit. So we've been able to create a way for everybody to communicate and work together. We're very excited to expand this out to remaining 500 nations that haven't attended a boot camp. And we fund this not through federal funds or state funds currently. We fund this through philanthropic efforts, like I said, Internet Society and a handful of others that see the value of this. Tribes have donated some of the funding, some of the catering, some of the event space. And, we're really geared up to try to make this successful without really taxing the tribes. In the cases of, travel, we have multiple travel stipends, upwards between 10 and 20 travel stipends for folks to get here that don't have travel budget or opportunity. So it's really, an exciting venture, and we're going to keep doing this as long as we have demand. The logos that you see on the right-hand side of the screen, ILSR is Institute for Local Self-Reliance. I would recommend that that's something that, folks check out, ilsr.org. Very good at researching and evaluating municipal networks, including tribal networks. The black logo is my personal logo. It's my initials. And then Waskawiwin, I just wanted to touch on for 1 minute, and then we'll go to questions. Waskawiwin is a Cree word from Alberta region of Canada, and that's where I'm from. And that word means the act of being active or the act of being in motion. We all feel in the broadband bootcamp space that we need to do, right? For decades, we've talked about the problem. We may have talked about a solution, but we haven't actually implemented anything. And those of us that are tired of talking about the problem want to do something about it. We want to create solutions and go after it. So that's sort of how that works. And that is a company that is being considered by the IRS for 501c3 status that will be the permanent home of the tribal broadband boot camps. So with that, I would like to open to questions.
All right. If you would like to get into the queue, you need to first be registered through the QR code. Raise your hand by going to the bottom of the screen. You see the hand, not the icon, in the middle of the screen. And click on that, and we'll start to manage the queue. If nobody has a question, I can always come up with a bunch. Well, let's start. So Matt, when you were when people are applying for federal funding, the U.S. federal funding, did you find that there were a lot of folks who just were flummoxed or just frustrated? And did you have to do any training there to help people out?
Yeah. Federal funding is often an onerous project, and the application process is quite involved. With the application for the NTIA funding called Tribal Broadband Connectivity Program, the application was extremely long and it was very detailed. Clearly, they were looking for shovel-ready projects that were at the point where they had already a general understanding of what they needed for their community, and they were looking to either further develop that or to start building that. And a lot of tribes weren't in that space yet. They were in the space of, hey, we think we know what we need, but how do we prove it? Like feasibility study, broadband plan, things like that. And so the funding was available to do both of those things, as long as they could get their head around applying for both of those things at once without having the broadband plan or the feasibility study and then trying to build a network off of it. So there was a round that allowed you to have $500,000 that could be applied to that, but you could also apply for that and the build at the same time. So it got really complicated, and we had to work with a bunch of tribes on their specific solutions because no one size fits all in Indian country. And then where there was, tactical or technical aspects of the application, we actually had to work with NTIA, get folks in touch with NTIA to be able to walk through the process. And as some of you know, and some of you don't know, they built the airplane after they pushed it off the edge of the cliff for this one. They did not have staff to support it. They did not have the application developed in the question format that they even wanted to report against. They've actually gone back since then and made made applicants of the first round readjust what they presented to better I don't know, to make it quantifiable or qualifiable for NTIA to be able to manage that grant moving forward. So it's been really complicated. Round 2 got a lot better because they had sorted out some of those bugs that they created while they were building the first one. But I'd still say it's not a perfect process. Federal government funding is tough to apply for. It's I've written applications as big as 120 pages long. I think this application was 85 pages long for some people. And you know, the application is one thing, but the reporting process is the next level of nightmare.
Thank you, Matt. We have Nalini Elkins in the queue. Go ahead, Nalini.
Okay. Hi, this is Nalini Elkins. Sorry, came out a little loud, with Inside Products. And I am just curious if you guys are, trying to use IPv6. Of course, you know how the IETF is about IPv6. And reason I'm asking too is I remember we worked with HHS, and worked with them to get them a hunkin' big old space, the technical term. And I believe we got it down to, I think the Bureau of Indian Affairs got a hunkin' big space too. So if you are not, and I'm doing V6 training at no cost for the government, and I'd be happy to do it for you guys and help you, because might as well leapfrog, right? Why?
Sure.
Why? Yeah. So if you are interested, I'm happy to work with you guys. Send you training. Do your address plan. I live in California. I can drive down there.
Cool. So yeah, some of the tribes are working with IPv6 space. Some of them on their new funding, they've decided to use that to help them migrate to that space as well in their new builds and their new process. So I would say it's not 50-50 on who's using IPv6 versus IPv4, but it's definitely something that is in play for some of the larger groups that need more space. So my contact information is in the chat, so just reach out.
Perfect. Thank you so much.
Thank you.
Matt, did you find that there were people squatting on the 2.5 gigahertz that were allocated for the tribes?
Squatting meaning
Using and not.
holding and not using.
Yeah.
Yeah, so the whole aspect of the 2.5 gigahertz, the reason it came into play is because the FCC saw it as it was being misused or not used, right? So really the applications where they did not pull the license back from the previous license holder is an actual university that was actively using it, or in the situation where a university had sold or sublet it or traded it somehow to a communications group. Those are the only licenses that didn't come back. The rest of it got pulled back, and as the tribes were applying for it, it was very apparent there were three chunks of the license, right? And so as they overlapped, if you got all three of them, you had a pretty reasonable solution to use for broadband deployment. But in a lot of cases, the tribes didn't have two of the channels. They only had one of the channels. So it's effective a little bit, but it's not as effective as having all three. There were squatters in some of those spaces, and those are still being undone today. Like they just awarded the Virginia tribes, I think it was 2.5 weeks ago. So that is still pending on a lot of places.
Any other questions for Matt?
I have one, but I'm just making space for other folks. So Matt, I think one interesting thing has been this transition from wireless to fiber, and I guess what have been the big foibles that have happened through these tribes learning to use and deploy and operate these technologies? I remember the stuff with we won't name vendor names, but the Hopi and their issues with their vendor. Have there been other sort of trouble spots, the fires that have had been put out, or has the technology piece sort of been ironed out?
I think because the evolution of technology is constant, I think you always have some hiccups here and there. We have the opening up of a new spectrum, and so a bunch of manufacturers try to jump in that right away. Maybe their stuff isn't bench tested or field tested yet, and they're not ready to go. So we saw that happen with one of the situations. In the fiber arena, we've seen people jump into that space with solutions for the home or solutions for splitters and things like that are not weather, that can't live on the res. I mean, the weather on the res is a little bit different than the weather in suburban America. Harsher conditions, desert climates, colder conditions in some cases, and so we've seen some equipment failures there. But really, it's a learning curve for industry as well as it is for Indian country. And I think as long as we have good relationships with our vendors, we have great results. If we have a vendor that comes in and sells you, all the product on the planet, but won't support it, won't treat you like an equal in that process, the same as they would treat the blue, red, or the yellow company in the United States, then I don't think you're going to have success. And we've seen that with vendors, and we've seen vendors lose traction with tribes because they are not a responsible vendor. They don't support their product after the sale. So as long as they support it after the sale, we've seen some great results.
Cool. Okay. Seeing no other questions, thank you so much, Matt.
Hey, thank you very much for having me.
Great to see you and be caught up on all this stuff again.
Yeah, absolutely. Good to see you both. Sorry I'm not there in person.
All right, next time.
Thank you, everyone.
I also uploaded them, so we can share them if you get stuck.
Can you go ahead and do that?
I think you should. My machine has been just absolutely flipping out this entire time. I have no idea what's going on.
Give me one.
Oh, yeah. Let me take this back.
I'm absolutely sorry.
Had some miscommunication. Or could I just use the clicker for control?
You can use the clicker. And then, let's see here. I don't see your slides, so give me one sec. That one? Voila. Okay. Yay. Bravo. You were being mysterious. There you go.
Sorry.
Over to Martin.
Yeah, hello, I'm Martin. I like to talk about the concise binary object representation for the web and DNS messages, which is the work I did together with Carsten, Thomas, and Matthias. The clicker doesn't seem to work.
I think I can help you.
Then I just...
Voila.
Yeah, next slide, please. So first I give an introduction, then talk about the evaluation of CBOR for web objects and evaluating CBOR for DNS messages, and then I conclude my talk. Next slide, please. So next slide on the introduction. So the global access to the internet requires fast internet connectivity and high-end devices, we say. Why do we say that? Next slide, please. It's because the message sizes in the web actually are growing over the past few years, and even with all the improvements that were done, this is a trend upwards. Next slide, please. And this conflicts, of course, with how the internet is posed worldwide at the moment. There are regions where the internet is very expensive. You pay a lot per gigabyte, and the page load sizes are very small. And this isn't even just a problem with developed versus developing world, but you also have rural areas in the developing world, in the developed world, where you have mobile access only, for example, to the internet, or very slow connection in general. And you also have people who just have devices that are very old, not up to date, and you have you can't not serve that ideal with them. Next slide, please. So how can we decrease the latency, which is the biggest issue here? We can get the object sizes smaller because JSON contributes a growing part to the transfer size, and we can also get other message sizes smaller, for example, with DNS, which always poses a big latency bottleneck to the web. Next slide, please. So we propose CBOR as a possible solution. the constraint is binary object representation, which is smaller than JSON. It allows for elision of message fields, and there's also an extension called packed CBOR, which allows for value compression. Next slide, please. First of all, why is CBOR smaller than JSON? Well, it's encoded in binary. As a simple example, I give here an integer. In JSON, this is 12. And this, of course, next slide, please, because it's ASCII, it's 2 bytes. And in CBOR, next slide, please, it's just a simple integer. And if you look at this integer in detail, next slide, please, you see that this is actually a CBOR header, which encodes the type in the first 3 bits, and in the remaining 5 bits, there is an indicator, which for this particular integer is just the value of the integer. Next slide, please. If we look at a more complex advanced example, for example, maps, next slide, please. There we see that the header gets a little bit more complex because we have a map now, which is indicated by the type 5, and the length, which is the key value, the length of number of key values in this thing. And the key here is a string, which is also identified by a type of length 3. And next slide, please. The floating point number, there you see an even more complex example where we have the type 7, which identifies the floating point number. And because, of course, this half precision floating point number doesn't fit into this 5 bits, the indicator now becomes just a value that says, okay, the value actually is in the next 2 bytes. Sorry. Next slide, please. And again, we can skip that too. Yeah. And the structure also, because CBOR is a structure type, we can also allows also for elision. For example, when you look at a DNS message that is then encoded in CBOR, we could, for example, use the message sections or, as a CBOR array, and this allows us already to elide the count fields of a DNS message in favor of the array lengths. You can elide the sections that are not used and use context clues instead. For example, if you have a query and you have only one section in there, it's probably the question, so just assume that it's a question. And you can also elide fields that with commonly used values. For example, most of the DNS messages on the internet use the in record class. So if that is used, just elide it. Next slide, please. So now we go into our evaluation. For this, first we look at the web objects. Next slide, please. For that, we collected JSON objects from GitHub. There were 123,000 JSON files from the repository we collected over a month. This collection also generated GitHub API traffic, which also is formatted in JSON. So we just took that as well, which gave us 164,000 more JSON objects, which totals to 287 JSON objects. And then we converted those to CBOR and measured the gain and byte savings, which you can see with the formulas down there. Next slide, please. And we get these results. And these don't look particularly well for some few of the JSON files. We have these very long tails to the negative end. We have also a very long tail to the positive end. But where do these negative tails come from? Next slide, please. These come from the way CBOR encodes floating point numbers, and it's particular when you have very long arrays with a lot of floating point numbers and they all go to double precision, you have a problem that this is growing very big. Next slide, please. So there is not much that you can do about this floating point problem, but you can fix the problem maybe in other sections with what we call domain-specific conversion. And for this, we particularly looked at GitHub blobs, which are part of the GitHub API. They basically represent the files in the Git way to represent files. So they are identified by a hash, a SHA-1 hash. They have a size, they have the content encoded in base 64, and also there is the encoding which states that it's base 64. Next slide, please. And we use this content actually to generate the JSON files we had in our file system by just decoding the base 64 and then dumping it in the file system. Next slide, please. But with CBOR, we now can use some features of CBOR, and namely here we use a tag. A tag is basically another type in CBOR where you can basically mark something. In this case, we use the tag to mark a t-string as a base 64. So we can remove the encoding property. Next slide, please. We then also can just encode the content completely in binary because CBOR is a binary format. So binary strings exist in CBOR, so you don't need base 64 at all. And you also don't need the size property because it's now encoded in the length of the binary string. Next slide, please. And you can also use, just because we know that these are JSON files, convert these again to CBOR and then embed them into the original CBOR file and using a tag that marks the binary string then as an encoded CBOR object within the CBOR object. Next slide, please. And with that, we get much better results. We still have some negative gain. This is, of course, because these are the JSONs that we've previously had. But we see that we actually get somewhat gain of nearly 100% for when we use the CBOR encoding for the actual, instead of the base 64 encoding. Next slide, please. And we also looked at the DNS message format, which we are currently discussing in the CBOR working group. Next slide, please. For this, we basically used, first of all, an IoT data set, which is constructed from 3 separate data sets, which basically provide some DNS data in a PCAP file. And we also generated our own DNS data by using the Tranquillus, which is a list of names, and requested several resource records for this at public resolvers, and then generated a PCAP file from that as well. And then used our converter to convert these to a CBOR-based format. Next slide, please. And with this, we have a similar picture that we already saw with the CBOR conversion, also having these long tails to the negative end, but we also have a very good compression for the most part. And there, these edge cases come from, next slide, please, from that there is no name compression in the base format for the CBOR format. And if we have a lot of names that are very same-ish, we get actually bad compression. So next slide, please. Name compression is needed in the unpacked format. Next slide, please. And for that, we propose name component referencing. So when you have a lot of names with a similar suffix, you split up the name basically in its component. Next slide, please. And then use a tag to reference these substrings of the name by basically just counting through the names. Next slide, please. And use that as a reference point for your tag. Next slide, please. And in our evaluation, we used 2 different tags just to see how the size of the tag, because of the encoding of CBOR, what impact this has on the size of the message. Next slide, please. And with this, we basically can improve. So basically, you see the orange lines, which uses component referencing, which pushes everything a little bit more to the right. So we have better compression ratios in general. Next slide, please. So in conclusion, next slide, please. We should make web and DNS messages smaller. We propose CBOR for this, which should be preferred over JSON, since it has more benefits than drawbacks. And the improved CBOR DNS message format should be preferred over classic DNS. And in general, we should look into protocol design that can decrease latency. So use raw binaries where possible over ASCII encoding. Use size-adaptive data types, like, for example, the integers I showed, and data compression where possible. And do not just convert blindly to CBOR if you use, for example, CBOR, but use also the features that CBOR provides. And yeah, if you're interested in this topic, please participate in our ongoing discussions. We have, separate from this topic, DNS over CoAP at the moment, working in the core working group, which will be on Wednesday, 9:30. And we also want to discuss this CBOR DNS message format in the CBOR working group. Sadly, I have to be on the plane for that already. So this is planned for IETF 121 in Dublin. So thank you. Are there any questions?
Hi, I'm Shane Kerr. So there was some existing work in DNS with the CDNS format.
Hmm?
Is the Is the reason that that wasn't used because it's because that's mostly for static data logs and things like that?
Well, it's mostly for storage, and so it does a lot of things where it makes things smaller, but for example, all this elision I talked about isn't done in that format, and so you in some cases actually get a bigger format than with normal DNS message format. I mean, the CDNS is more, as far as I remember, is more about instead of using zone files. So
The CDNS is definitely intended for message data, for packets. And I think in general, it is similar results, I guess, to what you see. You get like 10x improvement in size. So something to consider, but it may not be useful if it's not over a large set of data. Because I think a large part of the efficiency with that comes from, for example, storing pointers to specific data and then using that everywhere throughout. One other quick question is, did you look at the CPU performance of this?
We looked at the runtimes, and they were comparable to another. So we did it with Python just, but they were comparable to another DNS compositor, DNS Python. So, yeah.
Okay, thank you.
And could you announce who you are? Because I can't.
Oh, I just, sorry.
No problem.
I was too lazy.
Just for the record.
For the record, did this come through? Oh, connection recovered successfully.
It's all right. Go for it. But just announce who.
Now?
Yeah, there you go. Yours.
Okay, sorry about that. Yeah, cool things. Thanks much. I'm all for the idea. We are also working on accessible web, and so I'm all for the idea to reduce sizes. One of the things I may not have caught, you've shown this growth in web page size. Is there an indication of what the actual share of JSON compared to the total object size that you're retrieving?
Not in the data I showed, actually, but we had another, at least in the research paper that is currently under review for that, we had another paper that indicated that the JSON contribution to the web is actually growing. So,
okay.
Yeah.
Do you have a number?
It was in 2017, it was 4%, and it indicated that the growth was larger. So, yeah,
okay,
I'm aware that it's very old data, but yeah.
Just to have some ballpark, that was all I was looking for. Okay, yeah. Thank you.
Thank you.
Yeah, hi, Matthias. Just sorry, a small remark regarding the CPU and resource consumptions. I mean, all of these protocols are tailored for microcontrollers, for very small devices with very low resources and hardware. So I don't think that is an issue at all. And this is a little bit the broader perspective that we try to make a point here, that we have protocols that are tailored for devices that have low memory, low CPU, are battery driven, all of this. Why do not we use these protocols in the bigger internet?
Yeah.
And don't forget, I mean, there's also a lot of implementation already there, right? So it shouldn't be too hard.
Can I respond?
Sure. Can you say who you are just for the record?
Yeah, this is Shane Kerr again. I can log in if needed, but.
Go for it.
Okay.
Yeah.
Well, I mean, that's an interesting point, and oftentimes you will get great results by using techniques applied for low memory, low CPU, but not always. Remember that these small devices aren't looking to process tens or hundreds of thousands of packets per second. So the constraints are different, and you're not always going to get better results.
Completely agree. Depends on which part of the network you're looking for, right? I mean, for the servers, completely agree. Stub resolvers, for example, different story, I would say.
And do you have any more questions for Martin?
Sorry.
Thank you, though, for that. Any questions? Any more questions? Curtis will probably have questions.
I mean, I think it's sort of related to the last bit there, which is like, so like Quick is doing compression techniques. Obviously, this is all kind of like moving in the right direction, and in a way, like, there's a long history of this bit. I think DNS is really interesting, and that DNS was designed to be human readable. Same as
The message format for DNS?
No, sorry, I'm thinking of.
No.
What do I think of?
The one clear example is SIP.
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 Yeah, I mean, is SIP? Yes, it's got, I mean, yeah, so, it's not the only thing, I'm thinking of the, IPL, like your, local IP allocation.
DHCP.
DHCP is what I'm thinking of. And like, you know, that space of where they want things to be human readable because they're not going to do a lot of like big heavy lifting across the network and this stuff. And at the same time, like, you know, it's like clearly inefficient to use ASCII. And it's 2024.
Yeah.
So like, is this like, why now, I guess, is the question in a way. Like, everything you're speaking to, I think, has been the case for a very long time. And there's been other answers to the thing, like compression. Is it this move to IoT, which I think is a good answer, saying like now we have a lot of these smaller players? Is it your story of like
yes,
web pages are growing across the internet?
I mean, the story is basically, yeah, we have these protocols in the constrained IoT already, and they are coming to a point where they are quite stable. So why not use them for the larger internet as well? So that's why now. And on your point, we don't want to use ASCII. Many people still do with JSON or XML. I mean, yeah. And of course, they need to be human readable, but then you do stuff like minified JSON, which technically is human readable. But if you look at a minified JSON without a parser, you also will find some problems there. So, yeah. Yeah.
Excellent. Any other questions for Martin? All right, well, round of applause. Thank you very much.
Thank you.
All right, so we're going to transition to the panel on LEOs, low orbit satellites. And we have two panelists here, Jinping and Tony back. Can you guys come up? And we have two remote panelists for this as well. So we're going to try and do our best to figure this out. I think our last panel was fully remote.
Yes.
Yeah, so this will be our first mixed one. We're gonna have an adventure in how far this microphone can go.
Yeah, just watch yourself.
Don't go it. All right. So what should we do for the personal audience session? So we're going to begin by having the panelists give brief introductions to themselves. I guess we should start online. Joanna, Berna, are you guys ready?
How about we start with Joanna? Introduce yourself, Joanna.
Yes, I'm glad to introduce myself. Thank you very much for having us. I'll start with a confession. This is my very first IETF meeting, and I'm enjoying it already. Regrettably, I could not be there with you guys in the room, but it already sounds very exciting. The two presentations were informative, whereas they could not have been much more different from one another. My name is Joanna Kulasza. I work at the University of Lodz in Poland. I'm an assistant professor of international law and internet governance, but I also run a research center, which is called the Lodz Cyber Hub, and it focuses on the application of international law in cyberspace. And together with my good friend and colleague, Bernard Taligour, we have been engaged in a project that focuses on LEO-related policies. During these introductions, both Bernard and myself will take an opportunity to speak about the project a little bit more. It seems as if, however, that was the starting point for our work, that the technology is there. It has been there for a while, but because this new space race is gaining speed, the policies, as always, are not available. They're not keeping up to date. So the focus on that project has been to try and understand how international law or maybe national regulations can be applied to ensure sustainable internet access with the use of satellite-based broadband. I listened in very carefully into the tribal workshops that Matt described. We just hosted a summer school that was devoted to LEO-related policies here in which the temperature was a little bit lower, but I understand that the heat of the debate was almost as high. And we had a bunch of young academics here. We co-organized this event with the Global Internet Governance Academic Network, thanks to the kind support from Internet Society Foundation. And we put our brains together, try to understand how we might best support LEO infrastructures and their rapid development with the tools available in international law and internet governance. I'll stop here just for full transparency. I also wear an ICANN hat, so the LOT Cyber Hub is an at-large structure, and I have seen a few of my ICANN colleagues here in this room as well. I'm very much looking forward to the panel. Thank you for having me.
Berna.
Hi. First of all, I would like to thank you, Curtis and Jane, for inviting us to this panel to speak alongside Tony Lee and Jian-Ping Pan. I wish we could have been in Vancouver, just as Joanna said, but this year it didn't happen. Well, hopefully next time. A brief introduction of myself. I am a legal scholar specializing in international law, and I teach outer space law at Queen Mary University of London. And I'm also affiliated, I've become recently affiliated with the United Nations University, CRIS. They have a digital cluster, so we also conduct research there. Just before we started this project with Joanna, I was conducting research on 5G, and maybe the attendants there would remember the LEOs were initially introduced as 5G satellites. And so that's how it sort of came into, attracted our attention. And my initial reaction was to focus on its impact on global power dynamics and international law. And it was Joanna who raised the potential very positive impact on sustainable development goals. And so in the context of our project, we prepared the report. I shared the link in the chat. Joanna also shared the link shared the link for our other activities. So you can see there our report focuses on law and policy issues in relation to LEOs. And we focused on identifying the correct stakeholders and how to engage those stakeholders in law and policy making as it applies to these utilization of these new technologies to, in a way, to benefit most from them to support and enable the Sustainable Development Goals. So we'll talk more, but this is my brief introduction of myself and the project, and looking forward to your questions.
Great, thank you. Tony, do you want to go next?
Hi, I'm Tony Lee at Juniper Networks. This is not my first IETF. I've been coming here since 1991, and I'm a routing geek, for those of you who don't know me. I've been working on the satellite problem because all of the LEO folks that I've been talking to have decided that routing protocols don't work for us, so we're going to go do something on our own. And they are not feeding back to the rest of the world. And so what we're seeing is different proprietary technologies. This didn't seem right to me. So I sat down and tried to figure out, okay, what would happen if we actually did the impossible and took an IETF IGP and tried to route LEO with it. And it turns out that it's not too far off from where we are. I did have to make use of one experimental feature, but other than that, standard off-the-shelf ISIS works pretty well.
My name is Jian-Ping Pan. I'm from University of Victoria, just across the street from here, Vancouver. And my last in-person attendance to IETF was about 20 years ago in San Francisco when I was still working in Silicon Valley at that time. Of course, I've been following IETF, IEEE ASM all the time when I'm teaching in the university. But again, like it's good to be in person and see the, like Tony here as well. So our research has been into this like LEO space about like 3 or 4 years ago, like when we heard about this kind of Starlink, OneWeb, and other things as well. And particular to this particular kind of research group, the internet access for everyone, we also look into, let's say, kind of how to provide internet access in remote areas, while allow us to, let's say, kind of have internet measurement in those locations as well. So far, like for example, we have 4 dishes, like one in Victoria, one in Denver, one in Ottawa, and one mobile over there right now. And the interesting things that we found, like we do need a global network to observe a global satellite network as well. So I think like in this case, like IETF could be a very good venue for this initiative, which I'm going to like spend some time later to talk about as well. So just a quick introduction. I'm doing research in computer networks and teaching in university, but we are also like working together with our students, helping remote communities, indigenous like communities to get online. And meanwhile, kind of we do measurement at those locations as well.
Great, thank you so much. All right, so people should feel free to join the queue as you have questions. I'm gonna lead with a set that I've sort of pre-constructed. But we really want this to be a panel with some participation from the audience. So as ideas pop up about this space, please, again, join the queue. So I wanted to start by just kind of giving some background on why I put this panel together, which is that I've been doing work in the Canadian Arctic with an indigenous tribe up there, providing a community network funded by the Internet Society. And when we went up, it was probably, I guess this is the 3rd summer, we went up. They were supported by a satellite link that was in place. I want to say it was like Viasat or something, and probably Northwestel actually. It's like a 0.5 megabit provided for the whole village. All the kids were complaining that their PUBG was not going well for them. They had like 1 second pings on trying to play PUBG in the village out there. And we did some interviews and we installed the network, and then we're like, okay, we're gonna come back when Starlink turns on. And we came back the next summer when Starlink had turned on, and literally every house had one. Like the uptake was amazing. And it really reframed our work in a bunch of ways. I think it works really well with the kind of technology that we build. But in this era of, I would say, sort of outlandish hype cycles, we've been through Bitcoin. There's a couple distributed ledger working groups here. It's good work. But there was a hype cycle. Hopefully no one is going to push back on that. We're in the midst of the AI hype cycle. I feel like we're in the fall now. We've gone through summer. Things are starting to slow down on that hype cycle. And similarly, Starlink LEO has a feel of a hype cycle, but it's also one that I've experienced. Again, but if you go back historically, you go back to things like the Iridium network, which they stood up and it immediately went bankrupt. And the question is really whether there's enough of a use case for these kind of networks to make them subsist in the long term. Now, this is a panel that has made, I think, bets, career bets, saying this is a real space that's going to be around for a while. But I was hoping each one of you could answer why you made this bet. Like, what makes this feel like such a big deal to you that you're willing to sort of orient your work in that direction into the future, given the history of these sort of satellite networks not being overwhelmingly positive? So everyone can jump in as you see fit, but this is a question for everyone.
You want to say something first? Okay. So yeah, just as Kurt mentioned, like the LEO is not a new thing like anymore. That's first generation like Ethereum and other things as well. Teledisk, they all went bankrupt. Of course, like if we look at the networking perspective, for example, like if we can have fiber, just as the tribal network like bootcamp we've just seen, that's the best thing. But of course, there's certain, let's say, places we don't even have fiber, or the fiber is broken, or maybe the network is shut down by whatever reason. So in this case, if people need to communicate they probably need to communicate like in a wireless way. For example, we have a cellular system, but in the cellular system, you also need like a backhaul network as well. So I will call like this wave of LEO called a second generation. So we are like seeing the SpaceX Starlink. We are also seeing like the EU telesats like OneWeb, and there's also like things coming up, Amazon's Kuiper, and also the Canadian company called Telesat. They also have something called Lightspeed, promise to come in as well. I think right now, like we're in a much better position to see the growth of the LEO satellite network than the first generation. If you look at it, let's say Starlink growth, roughly in about 3 to 4 years, if you also count into the beta test like phase as well, they now have like more than 3 million users in, let's say about 100 countries, territorials, and the regions. And they claim like in all 7 continents as well. So of course, like the majority of the users, they are consumers, residential users, but they also have like commercial users, like in airplanes and cruise ships. So of course, in those places, that's impossible to have the wired network at all. So in this case, like I think this time, the second round for LEO, they do have a chance. And for IETF, we also should look into this as well, because just as Tony mentioned, like the routing protocols and other things involved, and we should like see whether the internet protocol designed for the terrestrial network can still work on like a LEO setting. And we also found some problems, and we also found some fix in the last like few years as well. So we can discuss this later, maybe in detail. Yeah, that's my take. I think the second chance might be better than the first like attempt by now, maybe like 30, 40 years ago.
So I'm sorry to say I have not bet my career on this. I'm still building core routers, and that's still gonna, but the satellite stuff, at least Starlink, has been very functional. I've had a good opportunity to use it twice, once on the Great Barrier Reef, once in the backwoods of Oregon just last weekend. It seems to work well. Now, the real question you're getting back to is, what are the economics of it? And I'm sorry to say I have not seen any of that. And even if I had, it would be under NDA. But there is a serious question here. And right now, Starlink is running off of deep pockets. I don't know what their operational costs are, but it's non-trivial, obviously. And so the real question is, are they covering costs? And my gut says not yet.
Joanna Berna.
I'm glad to start this off, unless Berna wishes to go first. Thank you. The conversation Berna and I had about this focused on whether international law has a role to play in this new space race. As international lawyers, we felt it should. As international lawyers working on internet governance, we were hoping it could be used to facilitate the multi-stakeholder model. Now, I am certain that in this room, the promise of the Tunis agenda still rings true. We still want to ensure global connectivity for the benefit of everyone that wishes to be connected. Now, if there is an mission that LEOs might have, it would be that one, to ensure global connectivity to those unconnected. During the summer school, we had a lovely French PhD student who studied the case of Nunavut in the north of Canada and the policies around it. So our task has been to try and understand whether the multi-stakeholder model still applies, and if it can help us in this shift to infrastructure in internet governance. Or maybe we should abandon these idealisms of early 2000s and say, well, it didn't work. Multi-stakeholder governance is a lovely concept, but since the governments have shifted to infrastructure, it's all national regulation. So, if, for example, a state like Israel allows Starlink into its territory, it has every right to apply its security and data governance laws to obtain data transferred through those infrastructures. these are open questions that Berna and I try to address as the global geopolitical landscape evolves. A local project that also attracted our attention, I have not heard yet mentioned, is Iris Square. So an attempt from Europe, broadly speaking, to facilitate its own technological autonomy, as we like to say, as opposed to digital sovereignty, and make sure that those satellite infrastructures are our own, are trusted, and whatever data travels through them should be compliant with GDPR regulations. So I think these were the open questions that Berna and I identified during one of our very first conversations, and we're still in an attempt to try and answer them. I'm going to stop here, and I'm going to give the floor to Berna to, I'm certain, provide you with more answers or guidance on where we stand with regards to that project. Thank you.
Yes, so I have something very short to add. We are not economists, but we have had the chance to talk to economists who had done research as to economic viability of this new type of connectivity. And from them, we learned that this type of connectivity has become feasible because of the decrease in launch costs. So the deployment of these infrastructures were very expensive before SpaceX came up with the reusable rocket technology. And with the reusable rocket technology, it became much cheaper to deploy numerous satellites in the low Earth orbit, thereby decreasing the cost of deployment of this infrastructure. And when we read the policy papers of different jurisdictions in relation to LEOs, we see that the commercial aspect of it is sometimes equally, sometimes even less, is perceived to be less important than its strategic value. So I think that also needs to be taken into consideration as to why certain regions or states are also investing in LEOs, although commercially it doesn't seem like a very profitable business investment. So this is what I wanted to add.
Yeah, that's an interesting point. And to add my own flavor on this slightly, like, yeah, I think the economic feasibility of Starlink on its own does remain suspect to me. I haven't seen those questions in particular, but again, it's like, even with these cheaper rockets, it's expensive. But then the idea that there's going to be 2 or 3 other players joining seems implausible. But at the same time, it's happening. And so I don't know if it's one of those things where things shake out. So there's, you know, the Sith rule of 2. There's always 2 players, and the third ones just fall out. Or you can actually create a competitive marketplace in LEOs. I guess we will see. I see someone in the queue, but I want to finish this sort of introductory line of questioning. So, and then we'll step out to the queue.
Can I have a quick follow-up?
Oh yeah, sure.
Okay. So talking about the economy, like kind of, so there's a few things involved. For example, like kind of, we have a cheap satellite and a cheap, let's say, rocket launch cost. But meanwhile, of course, the LEO, you have to like replace the satellite once every like 4 or 5 years. So that's what's continued cost. According to people close to Starlink SpaceX, like their investment is about $10 billion. And now they have like kind of 3 million users. And roughly speaking, kind of if each of them like pay, let's say $1,000, actually kind of commercial users actually pay much more than that $1,000 a year. It's already like kind of $3 billion a year. So that's why kind of no wonder people say like Starlink actually is a cash cow for SpaceX to eventually send the people to Mars, not here like around the Earth. So I don't think like enough, at least let's say for Starlink, according to their book as well, people question the book, but according to their book, they have been cash flow more than half a year ago. Let's say cash flow positive, they say. Again, like enough in terms of competition, Starlink is not the only game. We also have the Kuiper, but they need to get the satellite launched. But on the other side, like there's also service providers like OneWeb and Telesat, let's say kind of light speed, the target on more let's say kind of enterprise market as well. So I believe like kind of right now, like we see for the consumer, let's say kind of a market, we have the Starlink and eventually maybe the Kuiper, and for the enterprise, for the government, I mean even maybe military as well, we have like a OneWeb and also maybe hopefully the Telesat as well. So roughly speaking, like there's just space for those players, I guess.
So one thing that kind of dovetails off this discussion is the nature of a single large ISP as this foundational framework for connectivity. There's a level to which I am personally uncomfortable with the idea of like Starlink being the center of the internet for the rural world. And we talked about multi-stakeholder networks and how, you know, the internet is designed as a place for multiple networks to interconnect. And, you know, that's not the architecture. And so I'm curious about how you all feel about that. Like in a world where one or two of these LEOs starts to really dominate rural connectivity, starts to push out alternative solutions. Terrestrial wireless is sort of the classic competitor to this space. Is that a better or worse world for users and the internet? If anyone wants to jump in on that.
I'll jump in. So the first thing to remember is that Starlink has limited capacity. And as compared to any terrestrial backbone, what they have is trivial. You know, most of the core providers would take the aggregate capacity of Starlink's entire network and drop that inside of a single POP. So it's that small. It's a useful access network. I'm not arguing that. But it's just a drop in the bucket as compared to wireline. We certainly need more than one LEO provider. That's certainly viable. Whether we can support 3 or not, that's a very interesting question. And again, it comes down to costs. I don't know where that's going to shake out. I don't try to be an economist, and I certainly don't have the numbers for it. But it's certainly doable, and it doesn't scare me because I don't think that the existing access providers, terrestrial access, is going to go away because of this. Certainly some of the bottom feeders might get shaken out, but the primary ones I don't think are going to be significantly affected. And especially with 5G coming, I think we're going to see more competition, and that's very good.
Yeah, I can do a quick follow-up. So I don't think there's only like a 1 or 2, let's say, kind of, even for consumer market. For example, like both Starlink and Kuiper, they're US-based. Of course, they provide a global service as well. For example, let's say kind of Starlink and also OneWeb, by now they do have global coverage, but they don't have like a landing rights in every country right now. So for example, like kind of in Europe, they have a project called IRIS2, which is like kind of somehow they want to compete with Starlink. And I believe like maybe Russia, China, they can also have their own version of the LEO network as well. So definitely, let's say kind of there will be multiple, let's say kind of LEO net service provider out there, just like the terrestrial, let's say kind of a cellular systems. But from user point of view, I guess like one thing is important, that we want to have the roaming capability. So if you have like a dish with you, if you travel around the world, you hope like you can also hook up with different satellites or maybe different service provider as well to provide your service all the time. It's like you have to get a new dish, get a new set of equipment when you go to from another country, one country to another country. So this happened like by now 30, 40 years ago when we have GSM. At the very beginning, like your cellular phone only works with one provider in one country. Now like you can free roam, of course at additional cost. All around the world as well. So definitely the landing rights is something to make sure like eventually you're going to have multiple service providers, not only 1 or 2 from one country. The second thing is like yeah, I will just leave it here.
Bernard, Joanna?
Do you want to? Should I?
Go for it, Verna. It's all yours.
Okay, so competition is important, I think, in every industry, but when it comes to LEO broadband connectivity, I do not see. I don't think the competition should necessarily come from other LEO broadband companies. I think we should perceive LEO broadband as complementary to the global connectivity infrastructure. And we have had a chance to chat with a few government regulators, and none of the representatives that we spoke to these are outside the US, would consider relying on a foreign satellite infrastructure for a particular region in their country. So they would be willing to use it as backhaul. They would be willing to use it as an alternative. But relying solely on a foreign satellite broadband infrastructure was not, that was something that they didn't think would be acceptable from a autonomy perspective, sovereign autonomy perspective. So they were willing to benefit, but not definitely rely on it alone. And in the UK, the regulator, Ofcom, they are trying to create a competitive environment for LEO broadband companies. And for example, that involves placing gateways, the ground infrastructures, they are trying to position them strategically so that they could have as many companies as possible operating safely within their jurisdiction. And just as our fellow panelists mentioned, these regulators hold the ultimate decision-making power when it comes to landing rights. All of these companies need to acquire licenses and authorizations from each jurisdiction that they are willing to provide their services in. And the range of licenses and authorizations change according to the type of service that they are planning to provide. If they are working with the incumbent telecom operator, the licenses and authorizations are, the number of them are much less, and the time required to acquire that license and authorization is also much less, and so the cost is much less. But if they are willing to provide like Starlink directly to the consumer, then the whole picture changes. But then landing right remains within the sovereign power of the state that satellite company is willing to provide its services in. And it depends on that state whether they would like to facilitate competition or not. So I don't know if this replies to the question, but yeah.
I think so.
2 cents from me, just to complete. I do agree. This is largely an infrastructure question. The infrastructure falls within national regulations. It is a question of money and potentially, as we like to call it, digital sovereignty. I also note the interesting conversation in the chat, highlighting that infrastructure is infrastructure, falls outside of the multi-stakeholder model. That's something we've covered in our report as well. I'll just briefly try to address this, and then I leave it up to you, Curtis, to provide feedback on how we might wish to steer that discussion. I think what we're trying to address here is whether these new infrastructures that are rapidly developing, you called this a fad, and maybe that's all it is. Maybe this interest will fade out and we will come back to fiber, terrestrial infrastructures. We seemed to have missed the opportunity to provide input from the multi-stakeholder community for 5G. So I'm curious to hear feedback from the IETF colleagues. We were much too late for subsea cables. That infrastructure is out of scope for us. But LEOs are happening now. They're evolving right now. Is there room for this Tunis agenda promise to be addressed through the multi-stakeholder model? Or should we just drop our weapons and say, no, this is by far out of scope for us. It's simple infrastructure. States should regulate. Maybe the latter is indeed the truth. And as your question indicated, maybe we will come back to the old ways. But if there ever was a time to try and address infrastructure governance, then LEOs offer that opportunity right now. Within WSIS Plus 20, the Global Digital Compact also speaks about sustainable access. So if there is room for this unique idealistic multi-stakeholder governance model, then maybe the time is now. That would be, I think, partially an answer to your question and partially to address the very interesting conversation that is unfolding in the chat. I'm going to stop here. Thank you.
Yeah, I don't get to see the chat, unfortunately, so I'll let Jane manage that part. There's like a whole bunch of threads I kind of want to pull out here, but I also want to make sure the queue is now 2 people and there's some space for it. I do think that I want to push back a little bit on the like competition element of this, which I do feel like LEOs are in direct competition with terrestrial wireless. A lot of the stuff that Matt Rantanen is doing, and just as a concrete example, not picking on Matt's networks or anything, but those are folks who are going to debate, do I want to join the Hopi network or do I want to just buy a Starlink for my house? That is a decision that is present just over the last few years. And I think Starlink in particular has a number of advantages over those local networks. And so it seems to me that there will be some effects on those kinds of networks. I agree at a high level that the fiber networks offer fundamentally different service. And so if you need fiber level connectivity, Starlink will meet that need for you. But a lot of the wireless ISPs out there, I'm in the Facebook groups, which are delightful as little working groups. Like all it is them fighting with Starlink and trying to talk about how to convince their customers to stay on these local wireless networks, which often are more performant and have better responses, at least according to the people operating them. But don't have the cachet of a Starlink. So that was mostly just me kind of, I think, pushing back on that thought a little bit. I don't know if anyone wants to respond to that. Yeah, I know. I want to finish this thought before I jump into the queue, but okay, you want to go? Go.
Yeah, I can mention. So I don't think Starlink or LEO is to replace like the ground infrastructure at all. Like if you have ground infrastructure, whatever you have, let's say fiber, even like a wireless ISP, most time like enough they are cheaper and also like enough they provide a good enough service as well. Starlink is only for the place it's not possible to have a wire, let's say kind of on airplane or like on, let's say kind of cruise ship. In addition, like Starlink could also be the backhaul for these like wireless ISP as well. Because remember, like you do have a wireless ISP, but they need to backhaul into like some bigger cities into the internet as well. So in this case, like some of the service provider for that OneWeb, they targeting on like a kind of enterprise community network. Also, Starlink has something similar. They call like community gateway. So instead of have individual dish, like those like small dishes, now like you can also, let's say there's a one community dish, community, let's say gateway in Alaska as well. So basically, if you have a local distribution network, you don't have like a purchase dish everyone for every household, but instead you set up like a ground station there. So in this case, like this ground station can suddenly cover the entire city or entire remote town and things like that. I think there's competition, definitely. We like to think more competition, but there's more chance for collaboration among those service providers. Even for Starlink, majority of the traffic by Starlink is over fiber on the ground. They mostly can use satellite for the first like hop or the last hop as the band pipe. And of course, if you're on the ocean, they do use like intersatellite link as well. But again, like a majority of traffic that's still on the ground.
Okay, we will step into the queue. I've used my panel organizer chip for the first half of the discussion. But I think Faranza?
It's Farzan Abadi. Thank you.
There you are. Okay.
Hi, I'm Farzan Abadi from Digital Medusa, and thank you for the panel discussion. And Joanna and Berna have been following your great work on satellite internet and digital sovereignty. I just wanted to make a comment that if we want to know why we need a multi-stakeholder governance for satellite internet, it's just enough to look at the recent case that has been ongoing at the ITU, whereby Islamic Republic of Iran has complained that Starlink is being used in Iran and that ITU there is a bureau that considers these complaints, and that ITU should force Starlink to stop its services. which goes against our value of interoperable global internet. And imagine, and the reason that is that because also we have a multilateral process that is looking after this issue. If this process was multi-stakeholder, if this was ICANN, if the Islamic Republic had gone to ICANN saying that all the domain names of Iranians inside and outside should be all confiscated, what would we have said? We would have said, no, that's silly. This is why we need the multi-stakeholder governance, so that we can give the technical community, the civil society, the voice, and be on equal footing with the governments that are not all the time asserting digital sovereignty to protect their citizens, but to oppress them. And I've been working on this issue for the past year, but when I was looking at it, the satellite community is totally against like what we are saying, because they say that it's the satellite devices that have to be regulated in a multilateral fashion, because there will be technical issues. And I have not talked to them more than this. I think that the IETF community, it would be great if we could talk to that community at IETF, if we could talk to Starlink people to see how it can actually, like, we can actually provide access and not just ban people from connectivity and allow a government to disable access. Thank you.
What was the response from the ITU to that request?
So the case is still ongoing, but the preliminary ruling was that actually Starlink can tell where the devices are, and they should actually disconnect those devices that are connecting from Iran. But there are many. So the agency that is in charge of enforcement is in Norway. Norwegians and the U.S. also has jurisdictions. So the U.S. Government and Norwegians are providing responses of why it's not possible and a few other things.
Thank you. I guess this is a lead off for Joanna and Berna. Do you have a response?
I think I'm happy with what I initiated here. I'm glad to give Berna the floor first, and then I'll compliment. Is this okay, Berna?
Yes. Okay. So the ITU is tasked with coordinating and allocating frequency spectrum and associated orbital slots. So this is their mandate. Yes, ITUR only does this, and it has been working very efficiently and effectively over the years, because all of the satellites that are in the low Earth orbit, medium Earth orbit, geostationary orbit have been able to function without interfering with each other, other services, because this coordination mechanism works. And so the landing rights we had just mentioned had been a recognized way of providing services via satellites for many years. I mean, since the 70s, this is the basis upon which satellite services have been made available in a jurisdiction other than where the satellite is registered to. And so broadband services, connectivity services, broadcasting services, they're all based upon this understanding that where a satellite company is to provide services within a country, they need to get the proper authorization and licensing. So when it comes to human rights issues, the ITU does not have a mandate to regulate by considering the human rights, by taking into consideration the human rights abuses or issues. And if you consider internet access to be a human right issue, then then the multilateral or a civil rights organization that needs to push this agenda would be different, because ITU's role is very, very technical. And if you start changing the rules of the game, then it would be detrimental to all the other satellite services as well. So while we would all like to see that nobody's internet access is disrupted for unjustified reasons, the system in place works. And so I think the proper venue to discuss these issues would be outside the ITU, and ITU should continue its technical role in coordinating frequencies and allocating orbital slots or orbital planes where these satellite systems work. But I don't know if this is this answers the question, but I understand your concern and I empathize, but I think ITU is not the venue for that discussion.
Yeah, so I mean, I think that's a fine answer to say, or I guess an answer to say that, like, this is out of scope for the ITU by design. I am a little curious. It sounds like you know a lot about this. Like Starlink in particular is somewhat notorious for the roaming process working kind of everywhere. Like you can bring it to countries where there is no agreement and it'll turn on and just operate. How? Like.
Okay, so so far, what we have been working on, I mean, we have studied different use cases. So we have studied, Joanna and I studied how it was utilized in Ukraine, and then we wrote a piece on its use in Iran, and then the issue in Gaza. So Starlink, although owner Elon Musk, he pretends that he facilitates access via a click, on his phone or in his system. It doesn't really work that way. Even in Ukraine, it was made available upon the request of government officials of Ukraine. It was not made available in regions where Russia had occupied. There was the discussion, maybe the audience would remember, regarding Crimea. The Ukrainian officials wanted Starlink to be made available there, and because the Russian authorities would not allow that, Starlink services were not made available. They didn't open. I don't know the right word for this, but they were not made available there, within that certain region, and so the Ukrainian military could not use it. So this was sort of discussed as to the power of Starlink within a conflict environment, but it doesn't really surprise us from a regulatory point of view, because it is made available where it is authorized to do so, and it's not made available where it's not authorized to be. And so it was only in Iran where Starlink was made available, although there was no express government authorization. And that is because the US and Iran do not have diplomatic relations. In another jurisdiction where they have diplomatic relations, I don't think US would allow its companies to operate without proper procedures. So I don't know if Joanna would like to add something, but Starlink is really going by the rules, going through every regulatory burden and procedure. It is complying with the GDPR in the EU. So I mean, to me, it seems like they are trying their best to go by the rules. Well.
Thank you. Just to compliment, I believe neither Berna nor myself are trying to say that we need to change the way that the spectrum is distributed or broaden the scope of ITU. Maybe, but I think more what we're trying to do here, that's for you guys to decide, to give us feedback, is whether this paradigm we have for multi-stakeholder governance, and we have it for good reasons, once that Farti mentioned so explicitly, is there a way to use it to ensure global connectivity that is sustainable, accessible, based on those principles that need no reminder in this room that we put in the Tunis agenda? Or maybe we've moved away from that and it's all down to national regulators like that one in the US telling Mr. Musk what it is that he's supposed to do or that he is supposed to refrain from. I do struggle with this synonymous understanding of LEOs and Starlink. I think it's just an example. I struggle with this also with my students. When we talk about social media, they immediately think Facebook. There is so much more. So I think what we're trying to address here is that, as much as Berna highlighted this, Starlink is doing their best to play by the rules, however ambiguous these rules might be. But we're looking at different providers. They will come into the playing field, they will come into the foreground. And the question is whether there are universal rules to be applied. I see our next speaker in the queue taking the floor, so I'll stop here. We do want feedback. Thank you so much.
Yeah, camera on, you can jump in. Ignacio? You're muted. You are still muted. Yeah, he's. All right, well, while they figure that out, because he's gone offline and online and all this, I guess, like, just to push back slightly on this, like, I know, like, this is just an intriguing discussion to me, and I don't want to derail the panel entirely, but, like, I know some researchers in Uganda who turned on their Starlink before it was supposed to be available. Like that, again, somewhat notoriously. I guess something you're something to add as well.
Yes, somehow like the Starlink coverage is something like a myth there. They do have global coverage, but they don't have like global landing rights as of now. But how Starlink deal with like those roaming users actually is quite different. So if you look at, let's say, kind of in Africa, like even South Africa, when Elon Musk was born there, they don't have, let's say, authorized service yet, but they are users using Starlink right now, using either local or maybe like a regional or like kind of a global roaming service there. So I would think like kind of, again, like this needs to be discussed somewhere, but probably not only like the IETF or maybe ITU or ITOT, those type of places. Because somehow like kind of this is always like a mixed, because for telecommunication, starting for like a telephone service, there is always regulated by each individual countries. But for internet, computer communication, it was not regulated, at least at the beginning. But of course, nowadays, like there's more and more regulation to computer communication as well. For example, like all the Starlink users in Canada, they landed their packets in US because somehow like in the US and Canada, they're friendly to each other. So that's why kind of we have all the, like POPs in US, but instead like kind of in Canada. But if you look at like South American countries, almost every single country, they require Starlink to have a POP there, because they need to make sure like their customer, they are like a citizen, they land their packets somewhere in their own country, and they can do whatever they need if necessary. Another example I can provide is like the recent launch of the service in Indonesia, like for Starlink. So all other countries, like Starlink use the single autonomous system, that number, that's a 14593 for all the service. But by now, there's only one country exception, which is Indonesia. They have a separate AS name, AS number there. For whatever reason they want, but one possibility is like the country who give the license to Starlink to operate in a country require them to have a separate AS for whatever reason. So again, like I think there must be people like in Starlink or maybe in other those LEO companies as well. They have to negotiate with each country one by one. And it depends on the situation. They either like set up like a ground station there, or they have to set up a POP there, or they have to even set up like a separate AS number there as well. And this could be a very time-consuming task for them.
Yeah, but at the same time, I have friends who've been running Starlink in Indonesia for years at this moment, well before all of those deals got made. And so like, I'm just confused, I guess. Again, I want to be clear, I'm for it. Those guys, like, they've been providing internet to these communities. It's been awesome. But like, you know, the narrative is that this is not allowed, and that if you would say no, and I'm a little confused about circling that square.
Maybe I can shed some light. You only need landing rights where the ground station is, not where the individual dishes are. Home dishes basically will operate anywhere there's a satellite overhead. And for Starlink, that's now to the point where it's everywhere, pretty much. And thanks to ISLs, you can have a home station that has its packets landed halfway around the world. So basically, Elon can provide connectivity wherever he wants and can turn it on and off wherever he wants. And this is not a technical issue. So the real issue is about landing rights. And as noted, that's going to take some massive negotiations on a per country basis. Now, historically, ISPs have been under the influence and control of their national lawyers. It's been joked that an ISP is a building full of lawyers and one engineer. That's not far from wrong. It's not far from, well, anyhow, Starlink and other LEOs are going to have to sort this out. It's not going to fall under the multi-governance model. It's, we have never had influence directly over the ISPs. That's not what we do. That's not what we've tried to do. We manage the domain name system, we manage routing, and those things are not really under the purview of the governments. And that's the way it's broken out before, and I don't see that changing.
I'm not convinced that what you said there about the location of the ground terminals or the landing sites is the only critical piece of it. I think with the Iranian case is a good example. The lack of ground stations in Iran doesn't mean that Iran doesn't have a right to control the use of user terminals and their communications in the area.
Iran may have the technical rights to control their frequencies, but how are you going to get compliance?
Yeah. I mean, functionally, it's impossible. I completely agree. Like technically, there's not much to do about it. Anyway, I feel like Berna is the actual expert, and we should let Berna answer some of this, and then we'll jump into the queue again.
Every piece of the puzzle, every piece of the satellite technology requires a different type of licensing and registration. So the gateways is its separate license. The user terminals that you access the satellite service requires import licensing, and then there may be a series of other licenses for sale within the country. And frequency spectrum access requires a different license, which is usually granted via a auction. So all of these require different types of licenses. So it's definitely not only where you need a gateway you would be complying with the regulators' demands. It's everywhere that these satellites are providing services that they would need to acquire licenses and authorizations. This is the legal system. So technically, they may be available because the footprint cannot be exactly matched to the borders, the footprint of the satellites. And yet, because these satellites are more precise than their counterparts in higher orbits, it is more, their footprints are much more precise than those, older technologies. And so that is how Starlink was able to not turn on the services above Crimea, but right next to it, in Ukraine, right beyond the Crimean border. So it is not impossible to control the footprint, although maybe not exactly at the border that the country is willing to cut off the services. So with GEO, for example, there were famous disputes between the countries, because those that had not authorized would scramble the signal, and then that would also disrupt services in their neighboring countries. So this had been done. But with LEOs, this seems less of a problem. So we are not technical people, but this is how we understand from the ongoing negotiations and disputes. And definitely the licenses and authorizations are not limited to the ground stations. It applies to every piece of the puzzle. So.
Okay, well, we'll short circuit that discussion to get our person back in the queue. Ignacio, are you good to go?
Hi, everybody.
Thank you for. Sorry, it's okay?
You're good. You're good. Yeah.
Okay. Okay. Well, no, just to add, I know this is a very complex problem. The main problem is the spectrum is a limited resource, and this is why the ITU makes some agreement for every place, every region, and every country. And you can see this problem at the country with the mobile system, because in the mobile system, you have every country has, I don't know, 3 or perhaps 4 companies along every country to give the service. And this is because the spectrum is finite size. And well, for the satellites, the advantage is normally that they can use very higher frequencies that is used at the ground level, and you have the advantage these frequencies are not regulated yet, or they are in the regulation discussion at the very moment. But the main problem with the higher frequency is that perhaps you cannot enter to the or go through the clouds, or it depends on the weather, and also we have this problem of the borders of the countries and so on. But the advantage is that perhaps we can give service in place where it's not very easy to go by ground, just because the geography or the economics. For instance, I am from Argentina. In Argentina, we have a very large extension, places where we have no service of internet at all. And the satellite solution is a very good one. But sometimes there are companies like Starlink that give some services without the agreement of the government. And even if you have the agreement, you have to tax the people inside this country because the use of the service, and this is another problem. Therefore, it's really very complicated. But for the perspective to give internet access to the people, for instance, I am working in a project where we use, or where we plan to use, some satellite access to give a community of 20 houses service of internet. We have one dish for the 20 houses. This is the idea. And for this kind of project, it could be possible and very useful, this kind of connection. Therefore, okay, I think the multi-stakeholder is a good solution to manage that, but very, very complicated solution. In the other hand, the idea of the 5th generation of mobile communications goes in the direction of the multi-stakeholder, because in 5G we can mix several providers in the same antenna with different things. Therefore, perhaps we in the future will converge in the solution in the satellite services, but satellite services are a complement for the ground system, because the capacity, because several things. But it's very, very good for the places where it's very difficult to access. And I think it's really a good solution. And we have to work very hard to have the governance, to have the services, to have the people, and to have internet for everybody. This is all. Thank you.
Thank you.
Could I just briefly react to that?
Yeah, of course.
I'm aware of the time that is passing. Thank you very much for all of those interventions. As Berna highlighted, we have looked at different case scenarios, and what we're trying to find is a common denominator. I appreciated Ignacio's emphasis on the need to ensure access. So we hope that international law can be the tool to ensure that fair, open, universal access. We're looking at governments right now introducing policies. Thank you, Jane, for sharing those updates also in the chat, to try and limit connectivity. As you rightfully noted, Curtis, the technology is there. We have been working very closely with Dan York at ISOC, who presented a technical report on this, and it's conversations with him that have led us to believe that it's relatively easy to provide the service. The question is to make sure that those who use it are free and safe, and will not be punished in any way for disobeying national laws. Our takeaway from the work we had done thus far, and we do encourage you to stay in touch and provide feedback, is that the one point of pressure that we can exert right now is capacity building. Everyone wants quick, fast, efficient internet access. Very few, especially internet end users, are asking the question where that internet is coming from and who, for example, has access to the data. Satellite broadband is part of the Chinese initiative One Belt, One Road that invests heavily also in internet connectivity. So as much as we like to point fingers at Mr. Musk and say, well, he might have done better, is he compliant with the law? We hope that international law, as you will find in the report, but a series of publications as well, and we're always open to feedback, can ensure that we can counter these restrictive national, local, international policies before they are enacted. So raising capacity and having these discussions, to us at this point, I hope Berna agrees, is the one tool that we can do as academics to try and make sure that it's not broken and doesn't need fixing. I'm going to stop here. Thank you very much again for having us.
We have just 5 minutes left. And so we're going to go around with everyone just to kind of end with what you think is the big outstanding question. I think we've been talking about a bunch of questions and we might have some overlap in that. But with our last little bit here, and I'll start with Tony, what's the big question that you have in this space, TBD, to be resolved?
The real question is economics. Are LEO networks actually sustainable? And can we get to competition within them? If SpaceX are the only folks who have economic lift mechanisms, then who can compete?
Yeah, for me, I think the biggest question is like how to make sure like the satellite network will be as efficient as the other part of the internet as well. Meanwhile, like in terms of those regulation and other things, I think like we have seen something similar happened before, which is the kind of terrestrial mobile, like roaming systems. So at the very beginning, like each country have their own, let's say, mobile operator. They still have, but now they all have some sort of like a roaming agreement between them. So the users can actually go from one country to another country. So in this case, like this may happen to the satellite network in the future as well.
Well, do Berna?
Sorry. So I think the best, my dream would be a harmonization of laws and regulations so that this technology is utilized in the best way possible. And that harmonization would be possible with each and every stakeholder pitching in and addressing their concerns at relevant venues, not a single venue, but relevant venues. And when it comes to space and satellites, the stakeholders change. There are additional stakeholders in addition to internet governance stakeholders, and they should be taken into consideration as well. But we have reports on the website, so I won't go into further detail. Thank you. Yeah.
Thank you. And Joanna, you're going to end us.
Yeah, thank you. Famous last words. There's a policy cheat sheet on the website. If you want to have all of those questions condensed into 4 pages, it's right there. And it's also for civil society. To me, there are 2 buzzwords that we need to address. It's data and trust. So it's very important to know as an individual end user, maybe for the standard setting community, it is also a relevant question. Who has access to that data? Who can request access to that data? What is that data? Is it personal data? Does GDPR apply? Can we use GDPR to protect individuals that want to have internet access? And then it's about trust. It seems that Mr. Musk enjoys trust, but the next actors that might come onto the stage might struggle with that issue. We've witnessed this with 5G. I'll refrain from pointing fingers, but there seems to be an issue of trust with infrastructures. And if we can address it, we can ensure transparency and a legal framework to fall back on to secure that trust. We can safely move forward with this technology, be it a fad or not. I'm going to stop here. Thank you guys so much for having us.
All right, thanks. Let's say thanks to all the panelists, and then we can go get some snacks. Thank you, guys. So GAIA runs every IETF if you want to see us all in Dublin. And if you have anything that you feel is relevant you'd like to speak on, please reach out to Jane and I. We'd love to have you give a talk.